Welcome back to CircuitMeter Insights, the podcast where energy meets intelligence. Discovering how smart analytics, real-time data, and cutting-edge efficiency solutions are driving the future of sustainability forward. So, plug in, power up, and let's dive in. Today, our mission is to look at the very foundation of, everything in the modern digital economy, the data center.
Right. This is the infrastructure that's running everything from generative AI tools to global finance.
But this engine of innovation is running into a really severe global crisis, and it's all driven by one thing: power. Just power availability.
That is the core constraint. Power sourcing, capacity, that's the #1 challenge for data center operators right now. Doesn't matter if they're a hyperscaler in North America or running an enterprise site in Asia.
And it feels like we're at this unique moment where the demand, mostly from the explosion in AI, is just dramatically outpacing the supply of electricity.
It is, and there are hard numbers to back that up.
Go on.
In North America, the asking rates for data center capacity, so what people are willing to pay, they surged 20% year over year.
20%. And at the same time, the physical capacity is just vanishing. I was looking at Singapore, which is one of the most critical hubs in the world.
Oh, I know where you're going with this, the vacancy rate.
It's 1%. A 1% vacancy rate. You just can't find the space, or more importantly, the power to plug anything new in.
Northern Virginia is the perfect example. It's the largest data center hub on the planet, and its vacancy rate has dropped to a near record low of, I think, 0.9%.
Wow. 0.9%. That basically means there's no new capacity. You can't bring anything new online unless you find the power for it first.
You can't. And that's not just a commercial hurdle, it's systemic. The scarcity of power is fundamentally changing the industry. You can't just flip a switch and bring a new power plant online.
So the only path forward is efficiency.
It's the only path. It's mandatory now.
Oh, yeah.
And our research shows that to get that level of optimization, you need unprecedented visibility into your energy use, right down to the granular level.
Okay, so let's unpack that. We're talking about a global power cap. Every single milliwatt has to be accounted for, has to be optimized, and that's where a company like CircuitMeter comes in.
Exactly.
From what I've seen, they are fundamentally a data company. Their whole job is delivering this incredibly detailed, cyber-secure energy intelligence, and it's designed to plug right into existing DCIM platforms.
DCIM, right. Data Center Infrastructure Management. They're building that data layer you need to make all that invisible energy consumption suddenly visible and auditable.
So let's start with the immediate pressures, because it's not just a high utility bill, is it? The heat is on, financially and from a regulatory standpoint, especially in Europe.
Absolutely. The regulatory world is changing completely. The revised EU Energy Efficiency Directive, the ED, and for any facility over 500 kilowatts, it makes comprehensive sustainability reporting mandatory.
Mandatory with teeth.
With teeth. We're talking fines, penalties.
Yeah.
This isn't a suggestion anymore. It's a legal imperative.
So what are the specific things they have to report on to avoid getting into trouble?
Well, they have to track and disclose a whole slate of metrics. Their total energy consumption, their power usage effectiveness, or PUE. You'll hear that a lot in water usage, their renewable energy share. And this one is critical.
What's that?
Auditable data on waste heat reuse.
Waste heat reuse, that's a huge one. It forces them to see the data center as part of the whole energy ecosystem around it. If they can't provide that auditable data, it could stop expansion permits in their tracks.
And it would definitely impact their ESG ratings, which are becoming more and more important. And this all lands on top of their day-to-day operational challenges.
Right.
I mean, high costs are just built in. Our sources show that cooling systems alone can eat up nearly 50% of the total energy in a data center.
50%. Just on cooling.
Just on cooling. And when you add in these rising rack densities, you get these massive efficiency drains and, frankly, dangerous localized hotspots.
But the biggest challenge is what our research calls the visibility gap, right?
It is. Most facilities still rely on monitoring solutions that are complicated, they're expensive to scale, and they provide really poor resolution. They might tell you what the main PDU is drawing, but not what the individual circuits feeding the servers are actually doing.
And the tech driving these systems is often decades old. Our research highlighted the persistent use of protocols like Modbus. That sounds like a major constraint.
It's pretty wild how outdated some of the tech is. Modbus, while it's reliable for certain things, is extremely limited for a modern data center. It's slow. It's often restricted to managing just 247 devices on one network.
That's not much.
Not at all. And it requires these complex polling mechanisms that just bog down the infrastructure. Even worse, many systems still need manual setup, or they rely on web server communications that mean opening up firewall ports.
Which is a huge cyber risk.
A massive operational inefficiency and a security nightmare.
Okay, so if that's the slow, expensive, insecure status quo, how does CircuitMeter's approach close that visibility gap?
It's really about getting the data at the source, at the circuit level, and doing it affordably enough to scale across the whole facility. They use low-cost metering points to capture that granular data. But it's the quality and speed that are the real game changers.
What are we talking about in terms of speed?
We're talking real-time, 2-second interval data for immediate operational insight. And then you get high-resolution historical data, 15-minute intervals going back 10 years for that deep trend analysis.
Wow, that level of detail seems transformative. What can an operator actually do with that kind of forensic level data?
We call it forensic energy management. It means you can do a detailed demand analysis to precisely pinpoint the makeup of your facility's peak electrical demand.
So instead of guessing, you know exactly what's contributing.
Exactly. You know the exact mix of cooling, lighting, and computing loads. This lets you target specific, time-bound reductions and save significantly on demand charges, which can be a huge part of your utility bill.
And that also helps tackle unseen costs, like just pure waste.
The biggest one. Our research shows that just correcting operational inefficiencies, these are non-CapEx fixes like optimizing set points, that alone can yield 10% to 30% reductions in energy costs.
Moving beyond simply saving money, let's focus on the absolute priority, uptime. In mission-critical environments, a single unexpected fault can cost millions.
It can be catastrophic.
So how does continuous circuit-level monitoring translate into proactive risk mitigation?
Well, Granular data shifts the game from reactive to predictive. By monitoring electrical characteristics and identifying problems as they occur in real time down to the circuit, you can get notifications when power or thermal loads exceed preset thresholds.
Across individual PDUs or racks.
Right. And this prevents overloads and allows facility teams to target what we call just-in-time maintenance.
That's a powerful point, because traditional maintenance is often either waiting for something to fail, the reactive approach, or doing scheduled maintenance too frequently, which is the expensive over-maintenance approach.
Exactly. Circuit-level intelligence lets you perform maintenance exactly when it's needed. You extend equipment life, and you avoid those costly, unscheduled shutdowns.
And tied directly to uptime is cybersecurity. If you're constantly streaming high-res operational data, that pathway has to be bulletproof. You mentioned the risk of older systems punching holes in the firewall.
Unfortunately, yes, that's still a common vulnerability. And CircuitMeter directly addresses this. They've designed an architecture built for mission-critical security.
How so?
They use a proprietary bidirectional communication protocol that's designed to provide that high-res data reliably, but, and this is critical, it requires no opening of inbound firewall ports.
Okay, so that immediately reduces the external cyber attack surface.
Dramatically. It's a huge security win right out of the gate.
What about the data transmission itself? Is it encrypted?
Of course. The data transmission is secured using AES-256 encryption and SHA-256 authentication. These are the industry standards for mission-critical data.
And you mentioned it's more efficient than older systems.
Much more. Instead of that bandwidth-heavy TCP/IP polling, they use a proprietary UDP communication. It's highly efficient, minimal overhead, and it's perfect for reliable, low-latency data streaming in these high-density environments. It's just a complete upgrade.
Now, let's connect this visibility to these soaring sustainability requirements. It's no longer a nice-to-have, right? It's a global regulatory mandate.
We have absolutely entered the era of green accountability. The EU's Energy Efficiency Directive, or ED, is really the blueprint here.
And that requires mandatory reporting for any data center over 500 kilowatt-hour?
That's right. They have to report on total energy consumption, PUE, water usage, even waste heat reuse.
PUE being power usage effectiveness, that classic metric.
Correct. And that pressure from the ED is shifting the global focus. It's influencing policies from U.S. states to APAC markets like Singapore. So operators need tools that not only measure energy, but can automatically translate that data into compliance reporting.
So how does CircuitMeter's data directly help with that ESG reporting and compliance?
It serves two critical functions. First, it automatically converts the operational energy data into CO2e production data. That's carbon dioxide equivalent.
Which is essential for quantifying greenhouse gas emissions.
It is. And second, this high-fidelity data is used for audited measurement and verification, or M&V.
And M&V is important because...
Because it validates the real energy savings from your efficiency projects. This allows operators to capture valuable energy incentives and utility rebates. If you can't prove the savings with auditable data, you don't get the money. It's that simple.
Okay, so let's talk about the operational software layer. Data center infrastructure management, or DCIM tools, they're basically the nervous system for any larger facility, right?
I have to be. Once a data center gets past maybe 50 or 75 racks, relying on manual processes is just impossible.
And DCIM is supposed to bridge those functional silos, facilities, networking, systems, staff. But I imagine the DCIM is only as good as the data it receives.
That is the key challenge. So many DCI installations struggle because they're being fed slow, low-resolution data, or even worse, just static assumptions based on the equipment nameplate.
Which leads to inaccurate capacity planning and a lot of risk in load balancing.
Huge risk. And this is where CircuitMeter is specifically engineered to be that necessary foundational data layer.
Our research highlighted an active partnership they have with Hyperview, which is a leading cloud-based DCIM platform. This really shows the real-world application of this data flow.
It's a perfect example of how it's designed for seamless interoperability. CircuitMeter offers a global platform you can access in a browser, but the real power is the API.
So the API allows a platform like Hyperview to just ingest all that real-time and historical data.
From every PDU, every rack, every asset, Hyperview can then move beyond guesswork.
So Hyperview leverages the CircuitMeter data to make sure managers are making informed decisions. If the CircuitMeter data flags an anomaly on a specific circuit, what happens next in the Hyperview ecosystem?
Well, it allows Hyperview to enhance all of its core functions. Capacity planning becomes precise because you know the actual load, not the theoretical one.
Right.
Maintenance workflows can be automated based on electrical characteristics instead of just a calendar date. And asset management gains a real-time power signature.
So the partnership really means faster workflows and stronger ESG reporting.
And a much more intelligent ecosystem overall.
And focusing on that ROI again, where specifically do those savings materialize for the facility teams?
It's everywhere. From the cooling plant all the way to the rack, facility teams save huge amounts of time because they aren't troubleshooting with incomplete information.
They can tune things better.
Exactly. Optimized cooling set points, which are critical for PUE reduction, can be constantly tuned based on live load data. Precision maintenance avoids the downtime costs of unexpected failures. In essence, the data helps them avoid operational waste and lets them put resources where they're truly needed. It improves capacity planning and reduces all that stranded capacity.
The next few years will see an even steeper demand curve, and that's pushing us toward autonomous data centers driven by AI and digital twins.
This is the ultimate destination for sure, and it absolutely requires the highest quality, highest fidelity, live operational data possible.
You can't have a lag.
No. High-density computing, driven by AI, is forcing advanced management. And digital twins, which are these real-time virtual replicas of the physical data center, they just can't function if the data stream is slow, insecure, or coarse.
So if AI is the brain for automated optimization and decision-making, then high-resolution energy data is the nervous system.
That is the perfect analogy. The speed and quality of the data determine the decision-making capability of the AI.
And we don't have to wait for this future. It's unfolding now, right?
It is. Our research highlighted intelligent data center prototypes using advanced machine learning, specifically deep Q learning networks, or DQN agents.
Okay, can you quickly break down what a DQN agent is trying to do here?
Sure. A DQN agent is essentially an autonomous decision maker. In the IDC context, it learns in real time to balance these competing objectives. It wants to maximize PUE reduction, maintain temperature uniformity across the floor, and inhibit local hotspots.
So it's optimizing 3 variables simultaneously that no human team could possibly manage in real time?
Not a chance.
And what kind of results are these early applications seeing when they feed the AI this granular data?
The results are significant. By using real-time temperature and power data, the AI agent can generate optimal cooling policies that achieve substantial energy savings, sometimes upwards of 40% compared to a traditional constant temperature strategy. It demonstrates that autonomous thermal management is completely feasible, but the entire system breaks down without a reliable, high-resolution data source like CircuitMeter. This foundational data layer makes it possible for DCIM platforms like Hyperview to evolve into true AI orchestration tools.
So looking ahead, this foundation enables the full roadmap to the smart data center. We're talking automated load balancing, predictive electrical maintenance, autonomous cooling, digital twin modeling for simulations.
And continuous optimization. It's the essential prerequisite for next-generation automation. The age of intelligent infrastructure is here, and it's powered by high-fidelity data. So to synthesize everything we've discussed, data center performance today is really defined by three things: energy accountability, achieving and maintaining maximum uptime, and strategically preparing for the data-intensive future of AI. CircuitMeter delivers a scalable, cyber-secure, real-time energy intelligence layer. It improves uptime, it improves visibility on every single circuit, and it lets managers make far better decisions today.
And by making energy data actionable, DCIM ready, and supportive of critical ESG initiatives and incentive capture, it really does enable peak performance.
As data centers and AI reshape our future, CircuitMeter gives operators the real insights they need, revealing energy as it truly is, not how we assume it to be. And here's a provocative thought to leave you with. We noted earlier that markets like Silicon Valley are so constrained that developers are being told they won't receive traditional utility power for over a decade,
Forcing them to pursue alternative power sources like microgrids and large-scale battery storage.
Exactly. So this isn't just about cost anymore. This is becoming a foundational survival issue for the industry. When power is this scarce and this expensive, optimizing every single milliwatt with granular circuit-level data, it isn't just a smart cost-saving measure. It is rapidly becoming the only path forward for sustained growth and innovation.
A high-stakes problem that truly requires this level of surgical, data-driven precision.
And that's it for this episode of CircuitMeter Insights. We hope this discussion has powered up your understanding of how smart analytics, real-time data, and cutting-edge efficiency are transforming the energy landscape and driving the future of sustainability forward.